In this video, we'll be looking at section 3.3, linear versus nonlinear. And our essential question will be, how do I determine if an algebraic relationship is linear? So to make this determination, there's three different things we're going to look at. So I'm going to make a chart for us. So I need 3 columns. Like so. And the first thing we'll talk about is the graph or picture. And so the graph or the picture in a linear function is a straight line. So say we just drew a picture for that, something like this, and I just have 2 dots, and we connect them. And nonlinear would be a curve that is not straight. Which might look something like this. So the picture will want to plot the points, connect the dots, and then we make the decision. Is it a straight line or is it some kind of curve? The next one we'll look at is a table. So in a linear table, all x's change by the same amount. So if it's linear, all x's changes by the same amount, and all y's change by the same amount. So I go from 1x to the next, and if I'm going from -1 to 0, that's +1. 0 to 1 is +1. 1 to 2 is +1, and 2 to 3 is +1. So all my x's change by the same amount. If I do the same idea with the y's, 4 to 1 is -3. 1 to -2 is -3. -2 to -5 is -3. And -5 to -8 is -3. So I have all my x's changing by the same amount and all my y's changing by the same amount. So that means it is linear. And for nonlinear, one x does not change by the same amount. Or one y does not change by the same amount. So we could have a table. My x's can be, and then my y's could be. And then when I'm looking at my x values, I'm like, well, this is increasing by 2. This is increasing by 2. That one's increasing by 2. So my x's look good. All my x's change by the same amount, so let's investigate the y's. 3 to 0 is -3, but then from 0 to 4 is -4, and then from -4 to -7 is -3. So as soon as I have one time that it doesn't change by the same amount, it is not linear. And then the last piece is by looking at equations. So our linear equations have no exponents. Or y equals just a number. We could really think of it as if there's an exponent, any kind of exponent, whether it be a number or a variable, it's nonlinear. And anything without an exponent is linear. So for example, we could have y equals 3x plus 4. That is linear. There are no exponents. 4x minus 2y equals 7. It is linear. There are no exponents. Y equals 8. It is linear. There are no exponents. Our nonlinear has exponents. Or x is in the denominator. That's not linear. So for some examples of nonlinear, we could say y equals x to the third power. There's an exponent. We could say y equals 1/2 raised to the x. There's an exponent, not linear. We could say y equals 4 over x. X is in the denominator, not linear. Y equals 2 over x plus 3. X is in the denominator, not linear. We could have y equals x squared plus 7x minus 8. There's an exponent, not linear. So that's how we can identify whether these relationships are linear or not linear by looking at their equations, by looking at tables, or by looking at the graph or pictures. So thank you very much for watching this video. I hope you have a great rest of your day.